In this lesson, we introduce one-time pad. This is a scheme considered to be the strongest encryption method ever. First, we choose a long random bit sequence as key, which is as long as the bit length of your plain text. Then we use XOR operations on plain text and the key to generate the ciphertext. See here as the second row. It was sent over to the insecure channel and all saved in the storage. If we try to decrypt with a different key, like pad 2 here, the row number 4, will yield plain text 2, which is completely different from the original text. Fiber network has been used for a long time in distant telecommunication and data network. The same fiber connection can also be used to distribute one-time pad called quantum key distribution, QKD for short. This BB84 protocol was first proposed in 1984 by Charles H. Bennett and Gilles Brassard. It utilized fiber channel and polarization of the photon and quantum characteristics. Besides sending the photon in fiber channel represent 0 and 1, the photon can also be polarized using the filter very similar to the sunglass. The photon, after going through the first polarized filter, will be polarized in the direction of the filter axis. It can be vertical, horizontal, or it can be diagonal. If the beam goes through the second filters and the two filters are perpendicular, then no photon can get through. If the light intensity after the second filter is proportional to the square of the cosine of the angle between the two filter axes. Let's look at an example of the quantum key distributions. Here, Alice tried to send one-time pad to Bob, even though they recognize hacker 2D may be observing the object fiber channel in the fiber connections. Alice and Bob each has two sets of filters. Rectilinear basis, which means horizontal and vertical, and diagonal basis filter. Let Alice assign vertical as 0, horizontal as 1, lower left to the upper right polarization as 0, and upper left to lower right as 1. Given that pattern, and he will try to send this this kind of assignment, arrange the alphabet in the bit string, I should say, in plain text to Bob. Alice picks a one-time pad with information 100, 111, 001, 010, 0110 to Bob. Transfer them bit by bit to Bob using one of the two bases at random. Bob does not know which basis Alice used, so he randomly picked one. If he picked it right, he gets the correct bits. If not, he gets random bits. Bob tells Alice afterward, after the transmission, that the filter type he used either R type or D type in the plain text, receiving the plain text. Alice tells him which of them are right, which of them are wrong, And based on that, now they have the same understanding which are the correct bit to use as a one-time pad. Here is a picture of what actually happened based on that simple scenario. Alice picked a one-time pad, 100, 111, 001, 010, 0110. Alice randomly picked the filter type to send the signal. See row A here. The first signal is sent with diagonal filter. Upper left to lower right direction is 1. The second, using a rectilinear filter, therefore up-down polarization is 0 bit. Same for the third bit, and so on. Transfer this bit by bit to Bob using one of those two bases at random. Bob does not know which basis to use. He randomly pick one. Bob choose the pattern of R, R, D, 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 R, R as a filter pattern to receive. See row B, the second row in the setup. If he picks it right, he gets correct bit. If not, he gets random bit. Photon hit the filter with 45 degree to photon polarizations will randomly jump the axis, either filter or perpendicular to that. So this is how the quantum uncertainty principle characteristics is utilized here. Row C show what Bob received. Bob then tell Alice the polarization filter axis he used to receive in plain text. Alice tell him which bits are right and wrong in plain text is shown in row D for the result here. Now both of them understand they have a correct bit string of 010110001 shown in row E here. Trudy, on the other hand, use the filter pattern known in row F. However, the 8th bit, 11th bit, 12, and 15 bits, he guessed it wrong. And the random nature of the quantum phenomena leading to unpredictable bit pattern of those bits. Therefore, he didn't get the one-time pad. Here we show the real-world example where the quantum key distribution is used. On March 2007, Los Alamos National Lab and NIST carry out experiments. They demonstrate QKD can be transmitted over the fiber with a length of 148.7 kilometers. October 21st, 2007, QKD developed by ID Quantic company in Europe is used to secure the transmission of vote in Swiss election. 2015, Battelle, one of the industry company, using KQD to secure connect Columbus, Ohio headquarters, to their production facility in Dublin, Ohio, to make sure all the communication is secret. August 2015, University of Genoa and Corning company demonstrate they use KQD on a 307 kilometer fiber connections and was able to generate secret key at a rate of 12.7 kilobits per second. At the end of last year, 2016, China complete 2,000 kilometer quantum link between Beijing and Shanghai. It is reported in IEEE Spectrum October 2016 issue. These Beijing-Shanghai projects will form the backbone of China's quantum communication networks.